will cover combinations of functions and compositions of functions. Arithmetic combinations are exactly what you would expect them to be. If you have two different functions, f of x and g of x, and you are asked to add them together, it's just going to be a matter of writing this function plus this function and doing your simplifying. I'll do the simplifying on a couple other examples coming up. F of x minus g of x, same thing. The first function, 2x minus 3, minus, be careful, parentheses, x squared minus 1, because you are subtracting the whole quantity. You'd have to distribute the negative. F of x times g of x is just going to be a matter of putting the two things in parentheses because they are binomials, and then foiling them out. And division, same idea, just be sure you put the correct one on top. F of x is 2x minus 3, and the bottom is x squared minus 1. The only thing you got to be careful of on the division is that you must make a little statement over here saying the denominator cannot equal 0. This equal to 0, and factor it. Factors as x minus 1, x plus 1, so x equals 1 or negative 1 are the numbers that would need to be excluded from the domain because those would create 0 in the denominator. Speaking of domain, the domain of an arithmetic combination of functions f and g consists of all real numbers that are common to the domain of f and g. Most of the time you don't have to worry about that at all. It's when you get to the fractions and maybe roots that you have to think about the domain. Now we've got a little different notation. This right here, instead of doing f of x plus g of x, someone has decided to condense the notation and put f plus g together in the parentheses with the x out here. That means the same as f of x plus g of x. Same condensing, f minus g in parentheses x is the same as f of x minus g of x. Same idea for multiplying, and same idea for dividing. So you might still think this way because this is probably the way you learned in high school, but this is the new notation that goes with these functions 6x minus 7 and g of x equals x squared plus 4. I want to do f plus g of x. Now if you want to, you can rewrite this as f of x plus g of x. If that helps you keep straight what you're doing, then go ahead and write it down. I've already typed this in, so it's just a matter of us collecting like terms. This is your f of x, this is your g of x. All I have to do is collect like terms. I have x squared plus 6x minus 3. This is the result for f plus g of x. Over here, same kind of thing. F minus, be sure you put the minus in front of parentheses because you are subtracting the whole quantity. That means we need to distribute the negative through there, which is how we get this. Combine your like terms and rewrite it in descending order. Gives me negative x squared plus 6x. Put those together gives you negative 11. So this is your answer for f minus g of x. New functions, but now I'm going to look at f times g, which is just a matter of writing them next to each other and multiplying them out using FOIL. So this is what it looks like after I have FOILed. And then collect your like terms. We have 2x cubed. These are like terms, giving me negative 5x squared minus 3x. Division, put the f on top of the g. There's my expression. But I need to clarify that x cannot equal 0 and 3. And where that comes from is if I took this and factored this out, this is x times x minus 3, set it equal to 0 because we know we're not allowed to have 0 in the denominator, and solve those. That's how we get 0 and 3. This next thing sometimes is more complicated for people to learn. This is what's called composition of functions. We have two functions, but we're going to do this thing right here, f of g of x or g of f of x. Now these are different. The order that you write this down makes it different. And what we're talking about here is doing a substitution. We're going to take the entire g of x function, which is right here, and put it in place of that x right there. I like to think about these being two machines. This is my washer, and this is my dryer. So on a regular laundry day, you put stuff in the washer. You take something out of the washer. That's your output of the washer. And where do you put it? You put it in the dryer. So we are taking everything out of the washer and putting it in the dryer. What this right here does, it's making a new function, or it is making a new machine that takes you out of the loop. You don't have to take it out of the washer. It automatically jumps into the dryer for you. Be a pretty cool machine. So f of g of x is a matter of substituting in. I like to write this, put the g of x, actually write down 2x squared plus 4. That is your g function. And you know f of whatever means to plug that whatever in place of x in the f function. So this big mess is going in for that x. So this would be 2x squared plus 4 minus 3. Clean it up, 2x squared plus 1. This is different. This is like you put your stuff in the dryer and then it hops into the washer. That's not a cool machine, but it is a function we need to look at. So same process. F of x is better known as x minus 3. G of x minus 3 means this whole x minus 3 needs to go in place of that x in the g function. So this is 2 times parentheses x minus 3 squared plus 4, which is now just some FOIL work. X minus 3 squared, I'll come over here and write it, means x minus 3 times x minus 3, and you know how to FOIL that. When you FOIL and combine it, you're going to get x squared minus 3x plus 9, which is going to give me x squared minus 6x plus 9, plus this 4 that was hanging out here. Distribute your 2 is 2x squared minus 12x plus 18 plus 4 makes 22. I just have run out of room, so I did the 2 times 9 is 18, plus the 4 gives me 22. Notice these two are not the same. G of f of x and f of g of x are different. You know, if you put your clothes in the washer and then in the dryer, they come out looking differently than if you put them in the dryer first and then in the washer. Another thing you are going to be asked to do is to evaluate f of g of a number. This is easier to do. You have two choices. If you have already written up the f of g of x, then the easy thing to do is just take that 2 and plug it directly into your new function. So this is 2 times 2 squared plus 1. 2 squared is 4, times 2 is 8. 8 plus 1 makes 9. If, though, you have not done this new function, the easier way to go is just to work from your inside out. G of 2 means put 2 over here. So 2 squared is 4, times 2 is 8, plus 4 is 12. So that means we would do f of 12. F of 12 means to put 12 in here for x. 12 minus 3 is 9. So your choice for evaluating the number. If you've already done the function, that's easier. So g of f of 4 wants me to put the 4 into this function. So that's 2 times 4 squared minus, I just noticed this was supposed to be 12x up here, minus 12 times 4 plus 22. Arithmetic, 4 squared is 16, times 2 is 32, minus 48 plus 22. You can type that in your calculator or do it in your head, and you should get 6. This is a different notation than what you're probably used to, but it means the same thing. This O stands for of, so this is f of g of x, just like this was. And going in the other direction, g of f of x is the same as g of f of x. If you are more comfortable with this type of notation, which you might have seen more often in high school, then use it. All right, we want to do f of g of x and g of f of x for these two functions. So just concentrating, look at what's going on the left side. I want to do f of g of x. So if I want to do f of g of x, in place of this g of x, I'm going to place 3 over x. So really all I have to do is f of 3 over x. F of whatever means to place this in place of that x. So that's what this next line looks like. 2 on the top over 3 over x minus 1, which is a complex fraction. Remember, one way to get rid of these complex fractions is to take the denominator and multiply on the top and bottom by that denominator. I'm going to put this in parentheses because I have to do x times both of those. So the top of this becomes 2x. Here, those x's cancel, just leaving 3. X times 1 is x. Now that we have that expression, we do need to say x is not allowed to equal 3, because that would create an undefined situation in the denominator. The other one, this is g of x is 3 over x. I want to do g of f of x. So in place of f of x, I'm going to put this whole thing. So this is now g of 2 over x minus 1. G of this thing says to put this fraction in place of that x. So we would have 3 on the top over this going in for that single x, 2 over x minus 1. Back to a complex fraction, the easier way to do this one is to think about 3 being 3 over 1 and then just take the bottom fraction and flip it upside down. That's how it became x minus 1. Distribute gives you 3x minus 3 over 2. This example, we want to do f of g of x and g of f of x. Here's two new functions. Let's do f of g of x first. That's going to be on this side. So g of x is better known as this x minus 3. So I put x minus 3 in place of g of x. F of whatever says stuff this thing right here in place of that x. So that all we have is the square root of x minus 3. And we're finished. Over here, we're looking at g of x equal x minus 3. I want to do g of f of x. F of x is just the square root of x. So in place of f of x, I put square root of x. To do g of the square root of x, I'm going to place that square root of x in place of x. So this becomes the square root of x minus 3.